Hi guys, I'm doing this video on the day of the 2026 paper one, so hopefully everyone's had a good day. If you're obviously revising for future questions, but right, let's get into it. So question number 18, a curve C has equation y equals x cubed, take away 40x plus 1. Find the coordinates of both parts, or sorry, both the points on C at which the gradient is 8. So we'll have a graph. We'll have a couple of turning points, and at some point the gradient will be 8 on both of them. So we need to differentiate. So dy by dx will equal, and then I always sort of tell myself x squared differentiates to 2x. So you multiply by the power and then drop the power by 1. So 3x squared take away 40 with respect to x. So we now need to make this equal to 8. In order to solve it, 3x squared is equal to 48. X squared is equal to 16, and x is equal to plus or minus 4. So we then have to substitute 4 and minus 4 back in. So y equals 4 cubed, take away 40 lots of 4 plus 1. So 4 times 4 times 4 is 64. 40 times 4 is 160, and we add the 1. So 64, take away 160, add 1, and that gives us negative 95. So that's our first one. Just double check everything's okay with that. Yeah, I'm happy with those numbers. So 4 and negative 95. And then we need to do the same thing, but with negative 4. So y equals negative 4 cubed, take away 40 lots of negative 4 plus 1. So negative 4 cubed is negative 64. 4 times 40 is 160. This one will be plus 160. And then we add the 1 on. So 160 plus 1, take away 64, gives us 97. So that is negative 4 and 97. Okay, so I just want to run through a little check. And yeah, I'm happy with that answer. So I was expecting slightly different, but it could go really, 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 really high, really, really low, and the gradients of 8 could be there and sort of there. So yeah, bit of a crazy graph that one, but we've got the right answers. We have trusted the process. I'm just going to double check my answers while I'm on with you. Yeah, good. Okay, so next one. Question 19. Here is a quadrilateral A, B, C, D. Work out the value of x and give your answer correct to 3 significant figures. So actually, I've spotted it. It's quite a nice one to spot. If you know, you know, I guess. But we've got C, and then we'll call that little c, D, and little d. So we can use the sine rule for this one. So C over sin 62 is equal to 12.8 over sin 40. So C will equal 12.8 sin 62, because we multiply throughout by sin 62 to get it off the denominator of C, and that's all over sin 40. So 12.8 sin 62, I've just put sin 60, so that's rubbish. Good, and then divide it by sin 40, and I've got 17.58236938. Now, I like to write that in long form so that I can be accurate. Now, the next bit's tricky because we need to use the cosine rule, but they don't give you the formula to find the angle straight away. So a squared is equal to b squared plus c squared take away 2bc cos a. And we want cos a to be the subject. So the first thing we need to do is add all of the bit that is attached to cos a. So we've now got a squared plus 2bc cos a. We're going to take away the a squared, so that goes across here. b squared plus c squared, take away a squared. And then if we divide throughout by 2bc, we've successfully rearranged it, and we're going to be, well, that's a takeaway, we are going to be able to then use this formula above. Okay, so the next thing is I'm looking for x. So now this isn't going to be little c anymore, this is going to be little a for the context of this question. And then these two will form b and c. It doesn't matter which way around they go. All right, so 13.4 squared plus 15.2 squared, take away this answer 17.58236938 squared, all over 2 times 13.4 times by 15.2. Okay, let's get this in the calculator. 13.4 squared plus 15.2 squared, take away answer squared, because I've kept that long number in my calculator. I've just hit equals, and now I'm going to divide by and put all of the other bits in a bracket, so it's definitely multiplied first. Don't want any calculator problems. And my answer is 0.249067. Now, for me, that doesn't seem right, so I'm going to have to just run through a check and make sure that I've put everything correctly into my calculator. And now I'm just thinking, actually, it could be right, because I was expecting it to equal a squared. It's not. It's equal to cos a. So just to finish this off, we're going to hit shift cos answer equals. So shift cos answer equals, and that inverses cos, and we get 75.577637, which is 75.6. Okay, last one we'll do on this video. I don't want to get halfway through and get cut off. 4 marks. So the diagram shows a sector OA, B, C of a circle centre O, which means that's a radius. That's a radius. Angle AOC is 60, which is quite nice. The area of the shaded segment ABC is 38 centimeters squared. Work out the perimeter of the shaded segment ABC. This is nice, because that's the same, that's the same, so that's the same. So that's 60, that's 60. So that's a little bit of work done for us. In order to find the area of the segment, it's 60 over 360. Sorry, the area of the sector. Times by pi r squared. Then to work out the area of the triangle, and that's the bit that's been subtracted away from the sector, it's a half AB r squared sin 60. And all of this is equal to 38. So we need to find the radius, really. That's the thing we're looking for. Okay, so 1/6 or pi over 6 r squared. Take away, it's a sin 60. I want to know what sin 60 is. It is root 3 over 2, and then I'm going to multiply it by a half. So that's going to be take away root 3 over 4 r squared, which equals 38. Now my r squared, I'm going to take a factor of that out, which will give me pi over 6, take away root 3 over 4, which equals 38. Then I'm going to divide by all that. That's a number, so I can put that straight into my calculator now. 38 on the top of a fraction, so equals 38 over pi over 6, take away root 3 over 4. So that all goes in a bracket. Pi is there, over 6, take away, shift. No, need to get it so my square roots are only on the top. Square root 3, and then 4 at the bottom. Oh, syntax error because I haven't closed the bracket. Thanks, calculator. Right, that gives me r squared equals 419.4905. We'll square root that. How am I square rooting it? Shift, square root. answer, which gives me the radius as 20.48146795. Right, so that number is really important because that's AC. So AC is equal to 20.48146795. And then I need to find the arc length. So the arc length is 1/6 because it's 60 out of 360. That simplifies to 1/6 times by 2 pi r. So that's 1/3 times by pi times by r, which we also know is AC. So I'm going to now do, how am I going to do this? I might lose a bit of accuracy here, but we'll do the answer when it works times by 1/3 times by pi. So that value is 21.4481438, and then I'm going to add my AC because this value here represents this arc. The other value represents the distance AC, so I'm adding 20.48146795. That gives me 41.92961103, and then to one decimal place, 41.9. So that looks pretty good to me. And I've just had a quick look at the mark scheme. I'm correct, which is brilliant. It's saying allow between 41 and 42. So hopefully it's just removed the risk of any rounding errors. Okay, that's it for me for this video. I will see you at the next video. We've got question 21, 22, 23, 24, 25. I'll try and get them all done in one video, but that's 3 minutes a question, so it might be a challenge. But I'll see you next time.